The static keyword can be used to declare fields and methods that can be accessed without having to create an instance of the class. Static members only exist in one copy, which belongs to the class itself, whereas instance members are created as new copies for each new object. This means that static methods cannot use instance members, since these methods are not part of an instance. On the other hand, instance methods can use both static and instance members. To access a static member from outside the class name is used followed by the dot operator. This operator is the same as the one used to access instance members, but to reach them an object reference is required. An object reference cannot be used to access a static member. The advantage of static members is that they can be used by other classes without having to create an instance of the class. Fields should therefore be declared static when only a single instance of the variable is needed. Methods should be declared static if they perform a generic function that is independent of any instance variables. A good example of this is the system math class, which provides a multitude of mathematical methods. This class contains only static members and constants. Static fields have the advantage that they persist throughout the life of the application. A static variable can therefore be used, for example, to record the number of times that a method has been called. The initial value for a static field will only be set once, before it is first used. A class can also be marked static if it only contains static members and constant fields. A static class cannot be inherited or instantiated into an object. Attempting to do so will cause a compiled time error. A static constructor can perform any actions needed to initialize a class. Typically, these actions involve initializing static fields that cannot be initialized as they are declared. This can be necessary if their initialization requires more than one line or some other logic to be initialized. The static constructor, in contrast to the regular instance constructor, will only be run once. This occurs automatically either when an instance of the class is created or when a static member of the class is referenced. Static constructors cannot be called directly, and they are not inherited. In case the static fields also have initializers, those initial values will be assigned before the static constructor is run. A new feature in C# 3.0 is extension methods, which provide a way to seemingly add new instance methods to an existing class outside its definition. An extension method must be defined as static in a static class, and the keyword "this" is used on the first parameter to designate which class to extend. The extension method is callable for objects of its first parameter type, in this case string, as if it was an instance method of that class. No reference to the static class is needed. Because the extension method has an object reference, it can make use of instance members of the class it is extending. However, it cannot use members of the class that are inaccessible due to their access level. The benefit of extension methods is that they enable you to seemingly add methods to a class without having to modify or derive the original type.